Internet. All right. So far, we haven't done that. All right. Part of what I want to be emphasizing, the point is, don't become overly stipulated on any one variable. In the field of behavior analysis, we are overstipulated on level change. The reason is too many people only read journals where there have been whopping changes. And so if all the studies you've read all show giant change, it's too easy. The way you learn how to do visual analysis is not by reading published journal, it's by looking at the things that we didn't publish. All right? I've literally conducted hundreds of single case studies. Lots. I've looked at a lot of graphs. The number of things that I've done wrong is huge. All right? That's what will help you to become better. Now, I'm not saying do a lot of things wrong. I'm just saying that's part of the history that it takes. So level becomes less interesting when you've got change in trend and variability. Within phase trend changes your ability to talk about what, remember, I want two things. Tell me what the data say, and tell me the pattern of the data that is predicted. So look at how cute this is, right? Very nice, decreasing trend, we're all happy, and then you get this. And suddenly, it's really different. So is what you're predicting going to be based on the best fit straight line there, or probably much more here? The thing I really want you to notice is they were going to stop collecting data there. But because of this, they collected those extra 3 data points. How do you know when to stop collecting baseline data? Collect a minimum of 5 data points. When you're ready to bet next month's salary that you can predict the next 3 data points, then you're ready to stop. Said differently, when you can actually calculate a growth curve model where the confidence intervals are narrow. You know, it's not, nobody's excited if you say it's going to be between 0 and 100, all right? You got to have narrow confidence intervals, then you're ready to stop. So, take a look, here's another example. So within phase trends change. So this looks, you look at that, looks fine, but look at what happens here. Looks a little different now, doesn't it? So you really have one set of data there and another up there. If I were looking at this, I want to know what happened around days 9, 10, 11. You do too, right? What happened? And I don't know, but I want somebody to ask that question. Similarly, you look at this, and then you say, well, all of that looks fine until we say, add that variability. Changes what you're looking at, right? Changes your sense of what the data say. This is much more what you'll get from real humans. People do not behave with a level of consistency that make life easy. The point is, understanding the variability in human behavior is what creates science. All right? It is what really makes things work. So, let's actually test some of this stuff out. All right. So, if you really can do visual analysis, first thing you're going to do is say, do we have a baseline that works, right? If you don't have a baseline that demonstrates the effect, go and get a beer. You're done, right? Let the rest of the team do whatever they want. If the baseline doesn't show a problem, we don't, you know, or if we're making things that don't have a pattern we can interpret. So take a look. AB design. First thing you do is you look at the design. Does it have at least 5 data points per phase? Does it have manipulation of the independent variable? Does it have a minimum of 3 opportunities to assess the impact of the independent variable? Yes. All right. Well, if that's the case, then now I'm going to first look at level. Level, level, level. Changes. Now, but what I'm going to do is I now want to put that into a trend. So in this case, I'm going to just limit myself to best fit straight lines. So now I can talk about level change. But look at this. I'm getting pretty excited. I don't know about you. Not only do I have predicted level change when I do manipulation independent variable, I've got change in trend. Trend is going up, trend is going down, trend is going up, trend is going down. Woohoo! All right, well, let's put some confidence intervals around that. Now I'm going to actually do the neat thing. So far, I've only looked at observed data. Same graph. And all of the colored lines you're doing visually. You do not write any of this down. You don't never mess with the data. You present the raw data. Listen, I love that about single case methods. We don't average things and give you mean. We show you the exact raw data, and we tell you what we think. And everybody, God and everybody, sees the raw data, and they get to make interpretations. That's what's so neat about this as a science. Okay, so here we go. Now, if I predict, right? Look, that's what I'm predicting. Look at the difference between what I predicted and what I got. What's the likelihood that that would happen? So what's the likelihood if I did a growth curve model and I would say, it's not just a little, come on, this is not just a little, this is way down there, right? So let's do it again. Let's do it again. All right, so now I'm predicting this, and I got that. And now I'm predicting this, and I got that. Whoa! Are you excited, right? Even with the carbohydrates and everything. Okay. No, now look what you're just doing. This is different. This is visual analysis. Okay? So, comparison of similar faces, and we're ready to rock and roll. So now, the question before the committee. Do we have data that is within a design that documents, that has the potential to document effect, but do the data document a strong demonstration of experimental control, a moderate demonstration of experimental control, or insufficient? I don't want to say no evidence. Insufficient evidence of experimental control. All right. Well, you can do it with reversal designs. Okay? Now I want you to show me you can do it with multiple baseline. Now you're going to have multiple baselines that have 4 series, but the data get too small when I do that. So I'll show you some that are like that. But now, 1 demonstration of effect, 2 demonstrations of effect, 3 demonstrations of effect. Exactly the same thing. Level, trend, variability, overlap, immediacy of effect. So I look, what I predict, what I get. But then I'm going to add. Remember the thing to add? Visual analysis, vertical analysis. So I'm going to argue that these 3 data points, look at the gap here. So when we do this intervention, you do not intervene with the next person until you get an effect that is unexpected. So how long do you go? 3 data points? 4 data points? 5? You go as long as it takes until you've got a pattern that is different than what would be predicted. At that point, I want to say, these data, I do here say it, these data are different than we would have predicted from baseline. Okay? But I'm also going to say, look at participant B. No change. Participant C. No change. If this was due to the fact that David was teaching and everybody suddenly got better, they would have all gotten better. I think it's due to the independent variable. All right, but I'm not going to say that out loud. I'm only saying just between you and me. Not out loud until I look at, there's another change, and when I do it, no change in the other 2, and then I did it, and I get change in the 3rd. No real change in pattern. 3 demonstrations of effect, and in each case, the basic effect is there, and the vertical analysis demonstrates only change in the intervened participant.
Just want to point out here, this is an aspect of single case design which is very different from the group designs. It's an adaptive design. It changes as you go in response to what you see. You don't quit collecting baseline until you see stability. You don't change phases until you see stability in one, change in one, and stability in the others, and so on.
And that is the way that I have done it in every study that I've done. The only caveat I've given is that John Farron, Tom Crowderwell, Joel Levin are saying, you know, if you really want to even get fancier, you can randomize when you add things, and that randomization takes away the adaptation, but it gives you a new, all right.
You do that only if the baselines of all participants were similar. I mean, depending on the variable you wanted to change. If they were all so different, or you were dealing with problem behavior, you'd probably very likely want to start with someone whose problem behaviors were.
Oh, there's lots of good reasons
right.
why you would want to do it differently.
Right.
They're simply saying, if you want to take advantage of randomization, here's a way that you could do it. All right, so this is the intercept gap notion. This is a measure of immediacy of effect. You go to the line, the phase change line, and you extend the best fit straight line to that point. You extend backwards to that point, and you measure the size of that gap. It is a newer question. It's a way to look at immediacy of effect, and there's some indication that it co-varies with other strategies. You can do it both with multiple baseline and with, now there would be an example where very little, right? Very little. So we're still learning about that. I'm just letting you know that that's something that's on the table. Okay, so let's, I'm going to skip through this quickly because I want to give you some examples. So here we go. Do they have this piece of paper?
No paper, but on the slides.
You have the slides? Do you have this as a slide? All right, maybe, maybe not. Here's what I want to do. I want to walk through a set of graphs, and I want you to use what we've just talked about, and I want you to build fluency. All right? So if you're using a piece of paper, use a piece of paper, and what I want you to do is to assign a score between 1 and 7. So I want you to assign a score between 1 and 7. The question is, as a total set of data, to what extent do these data document experimental control? As a total set of data, do these data document experimental control? And I want you to argue that 5 means this is something that demonstrates sufficient control that you would consider publication. Now there are certainly reasons why you would publish things that were not statistically or demonstrated significance. There are a lot of reasons for publication, but 5 says this demonstrates an experimental effect. 6 is it's strong, 7 if it's super strong, 1, 2, 3, and 4 have compromises. 5 is the point where you would bring it to the entire academy and say, I, as a scholar and member of the academy, do hereby claim. All right, you got it? All right, so here we go. Let's do this. We're going to start doing it easy, and then I want you to get faster. Fluency is an index of accuracy, of command. So here's a study. I want you to do what we've already talked about. You always start by looking around the perimeter. So sessions is the time interval, percent of intervals with non-compliant behavior, percent of intervals with non-compliance. All right, baseline, we got a lot of non-compliance. So this is an individual human. All right, treatment, this is nifty treatment, reversal, treatment. So we got an A, B, A, B. So here's what I'm going to do. I'm going to hold the dependent variable, time, and treatment constant. The only thing I'm going to change are the data. So I'm holding all of the other variables that would get in trouble. So what I want you to look at is I want you to say level, trend, variability. Got it? Then I want you to project and compare these data, both with observed and with predicted. Is this a basic effect? Level, trend, variability, observed, predicted, compared. Level, trend, variability, observed, predicted, compared. Are there, within this study, 3 demonstrations in which the independent variable is manipulated and change in the dependent variable occurred is a predicted pattern from the logic model, based on the logic model? So let's make the assumption that treatment was designed to decrease noncompliance. All right. I would argue that on a scale of 1 to 7, this would be a 6. Anyone wish to make sense? All right, so put for reversal design